Hello and welcome to part 4 in a series of recorded walkthroughs of the United Kingdom Terminology Centre's Data Migration and Analytics Workbench. This is a proof of principle application written in Microsoft Access, demonstrating some of the properties and the possible advanced uses of the data migration mapping products and of the terminologies and classifications that they link. The application is divided into 4 main areas of functionality: the text-based console, which is displaying now, and more graphical tools for browse, query construction, and EPR data analytics, which can be started from the buttons at the bottom left of the console. This walkthrough provides an overview of part of the fourth of these areas, EPR data analytics. The analysis of coded electronic patient record data from populations of patients can be divided into 2 distinct areas of interest: data quality assessment, possibly including data repair, and then clinical reporting over highest quality data. This walkthrough focuses on the first of these areas, to identify and repair certain patterns of systematic miscoding in the initial data. At the left-hand side of the interface are a series of buttons that invoke various commands to import data, check and fix data errors, to cross-map to different terminologies and classifications, or perform various analytics functions. The results of these are displayed in the 3 panes to the right-hand side. The up and down arrow at the top will increase and decrease the font size in all of the windows. There's no patient data loaded into the tool at the moment, which is why all these panes are blank. So I need to get some from somewhere. One of the ways you can play with the tool without real patient data is to run the demo command from the console. This will ask you how much patient data you want, and if you ask for loads, it'll take quite a long time to make it. A small amount of patient data, so 1,000 fake patients across whom around 5,000 fake attendances are distributed, including some deliberate introductions of data errors, takes very little time at all. And if we flip back now to the EPR data module, we can see it populated with this fake patient data. We have just under 1,000 patients listed by their patient identifier, and each of them has an age and a sex, so pink background for a woman and blue background for a man, and a series of fake clinical consultations and codes, which are in no way age or sex appropriate. The algorithm is quite happy to assign gynecological disorders to male patients. Alternatively, real patient data from some external source can be imported using the Open dialog here, but it can take quite a while. I'm going to replace the fake generated data with this new data. The import format is described in the instruction manual for the tool, but broadly speaking, it needs a table of about 24 columns. The column names, this is a page from the manual, column names showed down the left-hand side, and an outline of what should be in those columns down the center, and the data type at the right-hand side. Within this 24-column table, only 3 columns are actually, or 3 fields are mandatory: a patient identifier, which is used for record linkage, the date of the episode of care, and the date of birth of the patient, and in addition, optionally, either a description identifier from SNOMED or a concept identifier from SNOMED. The orange rows are optional additional fields which you can add, which may increase your analytical capabilities: the patient's sex, some text fields to denote their ethnicity, the disposition, any other aspect of the episode of care, such as whether they were admitted, again ideally from a small and controlled vocabulary, identifier for the clinician responsible for the episode and possibly also for the service within which the episode occurred. All of the white fields are optional and can be left blank on the initial import. They'll be computed after the import by the machine. As I said, this import will take a while, about 6 or 7 minutes. So we've returned now a few minutes later, and the import of real patient data has completed. have data on around 180,000 patients, 400,000 episodes of care, and the patients are listed numerically by patient identifier in this box down the left-hand side, or at least the first 65,000 are in the list because of limitations in the list box component of the underlying access engine. In the center pane, the patient record of all episodes of care relating to the selected patient appears. Each episode of care comprises the date on which it occurred, and in square brackets the age of the patient on that day, the free text element that was signed up to by the clinician, and a SNOMED code that can be clicked on to reveal the position of that code in the SNOMED taxonomy. Patients relating to male patients, this M here signifies a male patient, are color-coded with a blue background, whereas female patients have a pink background. And the records can be variably long or short. In this particular data set, the first 100 or so records are patients with rather high, improbably high ages at the present time. These are probably patients who didn't have a date of birth that was known or stated because they were unconscious on admission. And because of the way record linkage works in this particular data set, some of those unconscious patients are all folded into single attendances with the same date of birth and ethnicity. So one of the first useful things to do after initial data import is a first check for data content and validation errors, and the check button serves this function, although the output is very crude. On pressing the button, the engine will go away and examine all the codes that were contained in the imported data for a number of patterns of miscode, and it's already reporting the raw numbers that have been found. So it's found a number of episodes of care that were coded using a SNOMED code which is now inactive, some that have been encoded using something which couldn't possibly clinically be valid, and others that are in varying degrees clinically unlikely. They may not be wrong, but they probably are. And having found these raw counts, it's now going to produce summary reports, some of which will be displayed on the screen and some exported to text file for offline viewing. This overall check report process will take quite a while to run. So here we are after the check for miscoding analysis has been completed. The report is presented in two ways. Within the native output screen, the most frequently encountered errors in the loaded dataset are reported, but a full report listing all errors encountered is exported within the clinical data subdirectory of the installation as a series of files with the .err extension. They can be loaded into an external text editor from the subdirectory that they're placed in, the clinical data subdirectory of the Workbench installation, and there are 5 of them reflecting a range of different coding errors that have been detected by the analysis. This report, for example, is the definite miscode report. Knowing that the imported data was derived from an electronic patient record, we might expect that the codes entered into electronic patient records would originate from the clinical findings or procedures hierarchies predominantly, and there are certainly some sub-hierarchies of SNOMED content that are inconceivable to enter in this context. For example, the semantic link hierarchy of attributes. This particular code, temperature, was presumably intended to mean the patient was pyrexial, but the code actually selected is not in the disorder or clinical findings hierarchy at all, and is therefore inappropriate to use in any context. The inappropriateness of this code is revealed particularly if you consider what would happen if we did a search for patients with pyrexia. This code could never be expected to be returned. Similarly, the followed by attribute has actually been selected because of one of its known abbreviations, FB, and probably in this case was intended to mean a foreign body was the reason for presentation of the patient. Transmitted by similarly has been selected for one of its abbreviations, probably in this case a patient with tuberculosis, and for some reason without the attribute has an abbreviation of MI, which is most likely in this case to have been selected meaning myocardial infarction. The other 4 reports in this series are similarly inspired and include lists of codes which are either unlikely or very unlikely to be appropriate in a clinical context, although perhaps not quite so definitely inappropriate as those in the previous report we looked at. There's also a report of all the items that have been encoded using a SNOMED code that is now inactive, and which therefore will have incorrect reporting behavior, and a list of cases where 2 different clinicians have selected the same synonym, the same piece of text, but from 2 different concepts. So here we have abrasion has been selected by several clinicians, but the code that it is attached to is different. One's a disorder, one's an abnormality, and one is more specifically a superficial abrasion, but the same piece of text has been selected. So these represent inter-rater variances. These reports comprise the data quality assessment, but they don't provide in themselves an easy method to correct these errors. In order to perform data repair, we need to return to the original application and to the Fixes option here. If I select the Fixes option, the first thing that appears is a dialog inviting me to load any previously authored miscoding corrections. This is so that I can apply the same fixes repeatedly to successive collections of data, on the assumption that my clinicians will be making the same mistakes over and again, and the same fix should be applied each time the error is encountered. For the purposes of this walkthrough, however, I'm not going to load any of the previously authored substitution files, and I'll skip this step. The tool will then go on to perform a detailed analysis, more detailed in fact than the previous 5 reports, looking for cases of miscoding and wherever possible trying to suggest an appropriate correction for it. Once the analysis has completed, you get a screen that looks like this. Note also that the Fixes button has switched to showing records. This is to tell me that if I click this button now, I will revert to the view of browsing individual patient records. The list of fixes is displayed as follows. In this column is the concept which has been deemed to be probably or definitely an inappropriate miscoded concept, and in the right-hand column is a suggested replacement. The list of suggestions has been found by a variety of techniques. For example, in the case of those with a little X in the second column, these are all inactive concepts in SNOMED. So, for example, leg swelling is now an ambiguous concept in SNOMED, and the machine has selected one of its alternatives, swelling of lower limb finding, as being a possible alternative. In other cases, the replacement has been put in by hard coding within the application itself. So the mapping between high temperature, a physical force, as a miscode, and a clinical finding of fever is one that's hard coded within the application itself. Across the top of the report is displayed a summary of the situation so far, in this case telling us that the machine has identified 1,830 individual codes which are probably miscodes, and that the total number of electronic patient record items coded using at least one of these miscodes accounts for about 10% of the entire coded content. It's also saying that out of the 1,800 miscodes, there are still over 1,200 that need a fix to be declared. Although the number is fairly large, this only accounts for about 2% of the overall EPR content, because most of the very frequently used miscodes have been found a fix by the machine. From this point forward, the role of the user is to validate that the suggested miscode corrections are in fact correct before applying them systematically to the record. Also, particularly for the very commonly encountered miscodes, to identify a suitable replacement where the machine was unable to. So in this particular case, for example, the immune hypersensitivity reaction concept is now an inactive and ambiguous concept in SNOMED, with a number of possible alternatives. In this case, allergic reaction seems like a reasonable alternative. So I can select the code on the right-hand side and add it as a fix. In other cases, the machine may not be able to be so helpful in suggesting an alternative. For example, here we have items that have been selected, coded with the code entire elbow region, a body structure. So technically this is just saying the patient has an elbow, which is hardly a clinical finding. More likely is that the original intent was to state that the patient had an elbow disorder. And in order to find that concept, I'm going to have to search for it lexically using the search window in the bottom. So the code we want is probably in this list somewhere. Yep, disorder of elbow. So I'll substitute that one as a fix for the statement that the patient has an elbow. In other cases, when we look at the list of suggestions that have been made by the machine, we may disagree. So, for example, this code, fitting procedure. We could look at that and say, does that mean the patient is fitting? It's rather odd to have selected procedure. This procedure code could mean fitting a prosthesis rather than the observation that the patient is having a seizure. But if we look in more detail at the information at the top right, which is rather small in this view, it says that every single time a clinician has selected this particular code with the preferred term fitting procedure, the synonym they've selected is just fitting. So given the context of an emergency department, it's likely that this is a correct substitute and they really intended to state that the patient was suffering a seizure. And so the data curator should continue through the list, populating wherever possible on the right-hand side with a substitute where the machine could find none, and correcting or deleting substitutes where they disagree with the machine's suggestion, bearing in mind all the time that as we get to smaller and smaller numbers of individual electronic patient records that use the miscode, the return on investment becomes very small. At any point in time, the curator can save the current state of affairs to a text file externally, which can be reloaded as before. And when the list is stable, the next step is to apply the fixes to the loaded patient data in the background using the Apply Fixes button. I'll flip back to a records view before doing this. Now we'll apply the fixes. We'll see the first thing it does is yet again to force an export of the current state of the fixes, and then it applies the fix substitutions to, in this case, 36,000 episodes have had their coded assignment changed according to the substitutions declared in the fixes. Once we've done that data repair, it's now a suitable time to add any crossmap information. So at the moment the data is entirely and only SNOMED coded in the background, and we've just changed some of those coded items to correct systematic miscodes. But we may wish in subsequent analyses to be able to analyze the data according to, for example, an ICD code, OPCS code, or other coding schemes. So the Map button will go through the list of codes in the table of electronic patient records, and for each of them work out whether or not there is an appropriate cross-mapped code in the target schemes of Read Codes version 2, Clinical Terms version 3, ICD, or OPCS 4. And as that mapping process proceeds, we'll see the results spit out in the dialog. So now we've completed the initial import of data, done a basic data quality check, applied some data quality repair fixes, and cross-mapped to external terminologies or classifications. So now the data is as good as we can get it, and we can begin with some basic analytics. These analytics functions are covered in the next section of the recorded walkthroughs. And that concludes this part of the walkthroughs of the Data Migration and Analytics Workbench. Thanks for watching.